Hi, my name is Julia Schub. I'm the DevOps lead at LogGeeks, and we are here to talk about developing software for Kubernetes, a survival kit. The meetup tonight is going to be in English because we have a lot of joiners from abroad. So since everybody's native language here is Hebrew, we apologize for the occasional slip up, or in case anybody doesn't understand something, we can stop and translate. Other than that, we have awesome pops that you can that we're going to raffle off after the meetup, after the panel is done. And I think that's about it, and we can start. I'll let our panelists introduce themselves, and we're going to start with Liri.
Hi, I'm Liri. I have about 10 years of experience, mainly in developing backend, and the last 4 years or so deep diving into the world of Kubernetes and cloud. Today, I'm a tech lead at Apiro. We are doing application security, mainly focusing on the diagnosing and deep diving into the code and the analysis of code.
Hey, I'm Guy Menachem. I'm a solution engineer from Komodor. Before that, I was a software developer at Zadara. In Komodor, we are doing a Kubernetes native troubleshooting platform, which enables Devops to troubleshoot easily in Kubernetes services, and actually closing the gap between DevOps and developers while they're doing troubleshoot.
Thank you. Hi, everyone. I'm Tomer. I used to lead solution engineering at Spot by NetApp, where we specialize in delivering autonomous infrastructure that helps developers kind of not think about infrastructure and tightly tied to application needs. I currently lead a global cloud acquisition strategy as part of NetApp after we got acquired last year. And thank you for having us here.
And I'm Gilad Weiss. I'm a full stack developer at Rookout, but mostly in backend and architecture. In our company, we do a platform for devs that let them control their observability on their own platforms, on their own apps, having logs and other traces and everything you want to know from a code that runs on production without stopping the code or redeploying.
So first off, thank you to our panelists for being here. Thank you guys for coming and coming to see us. We have a lot of people in Zoom, so thank you guys for joining as well. The meetup tonight is going to be recorded and then uploaded to YouTube, so please mind the camera and don't pass too much in front of it. And on that cheery note, we're going to start with Liri, and the first question is, what's your survival kit?
Okay, so basically, we're developing applications for Kubernetes while in mind having lots and lots of different approaches to developing for Kubernetes. If you want your app to remain agnostic to whatever environment it runs on, you need to think ahead and plan ahead. What I mean about that, you have the standard Kubernetes of running on some cloud provided cluster, managed cluster, but that's not enough. You have all kinds of clusters. You have Google, AWS, and Azure, of course, whatever else there's out there. And each of them have their own little tweaks that you need to know about. You need to understand that Kubernetes is not providing everything out of the box by being Kubernetes. You have lots of stuff around it. And for that, you need to be aware of the differences between running in the different cloud providers and also when running outside of that. If you're running on a customer managed cluster, which might be bare metal or OpenShift or whatever, or if you're running on your own cluster, which you manage, either in a customer environment or your own, you need to be aware of the differences of what makes a cluster actually function. All of the small details of architecture means a lot when you are developing and making up your application. You should have that in mind.
All righty, so I think we're going to start off by mentioning that after each of our panelists is going to start with their discussion, you guys are free to raise questions or anything else you like. But my first question is, what's your favorite flavor of Kubernetes? Where would you prefer to run?
Well, so I had the pleasure of deciding for our company where I want our main platform to run, and that's Google. I think it is the most friendly interface and command line and all of that around it. Noting that, I think that you should still be aware of the of what makes it different, and by focusing on what's good in, say, Google, you can understand what you should focus on when looking at other cloud providers, either for estimating them if you want to run them, or if you need to, because you have business requirements or because your customers demand that.
Did you find yourself having to deal with other orchestrators other than Kubernetes? I'm talking like wild stuff like HashiCorp's Nomad or like ECS, which is quite different.
Yeah,
Docker
so
Swarm, Docker Compose, because how do you say it isn't Kubernetes if it isn't run in France in a specific region of Kubernetes? Other than that, it's just Docker Compose.
well, what's pretty amazing is that everything is built on top of containers. So you'd think they all look the same. They're all running containers and orchestrating them, but no, they have each their own mindset. And I did not actually deep dived into any of the other ones besides taking a look at their, say, approach and promises and saying, no, Kubernetes is better.
Talking about Kubernetes is better or whatever it is you want to give to your customers, there's always the issue of security and how you secure your cluster. Is this something that you care to share from your experience on how you guys secured your various clusters on various flavors?
Yeah, so basically when you're running on a managed cluster, be it Google or whatever, you have lots of advantages that come from the fact that your cluster is managed. You don't know that by default, but the cloud providers do a lot of work for you in terms of security, in terms of access control and whatnot. And you need to be very minded about that when you're managing your own cluster. For example, if you are looking at the master node or the control plane, it has all of the power to do anything in the cluster. If you have access to the actual node of the control plane, you basically can do everything because you don't need to do any further authentication. By default, all of the certificates or whatever you need in order to make any commands against the key value store or against the API server that actually manages the cluster. All you need to do is to reference the files, which don't have any encryption on top of being on the file system with certain permissions, and you can probably do whatever you can, whatever you want. So in the cloud managed provider, the master is actually not available to you not as an administrator, and of course not as a user or an attacker. While the IP might be public, if you choose your cluster to be public, still you cannot easily access the cluster. You should still note that you have lots of powers only by accessing the node. Any worker node, which is not running the master, is still running very powerful beings. On top of them is the kubelet, what's running the actual mind of the node. It accepts commands from the API server, which is on the master, and it can do anything that the node has the need for. What's that mean? Actually running your code, whatever is scheduled on it. It can access secrets that are in any relationship with this node, and anything else you can extend from that. So when you're taking all of this into a different architecture in, say, a bare metal installation, you need to be aware of how much power you can have by simply accessing any sort of orchestration level of the cluster. Of course, when you have access to the entire machine architecture, you have power for everything. And from there, your security is more focused to the orchestration level, the code. Of course, you don't want the code to be able to actually do anything on the host. But if you have power of the host, you have power of the code. Yeah, because you have access to the actual images and you can communicate with the process and do whatever you need. You can read the memory, which may contain secrets. Even if they're encrypted at rest, they might not be encrypted at transit, whatever. So many concerns.
And if you had to take away, I don't know, a single or two pieces of advice for someone running self-hosted clusters in terms of security, what would be the first thing that you would tell people to notice and fix?
Well, so there are lots of hardening guides and whatnot. You can read through them and you will have a lot of fun. But basically, the stuff that you need to be aware of are the security measures, which you, even in a cloud managed provider, you won't get by default. So for example, Kubernetes is very strong in the terms of RBAC, role-based access, which gives you the ability to granulate which resources are accessible. For example, you can access pod information, but not secrets. That's obviously very good, but by default, your users will probably have access to the entire resources of the cluster. For example, in Google, when you give a user the permission to read your Kubernetes cluster, you practically give them the ability to read anything on the cluster. So for example, they can read secrets and they can read tokens and whatnot. That's probably not what you meant by giving them read access. So you need to note that even if Kubernetes is managing roles internally and has lots of configuration, you should still note what you give your tools, be it users that are using kubectl to access the cluster. And moreover, when you use external tools, for example, dashboards or I don't know, monitoring services, they might have a lot more power than they should. Besides that, you should note stuff like networking. Obviously, I mentioned the master is the most important part. You don't want anyone to be able to access the master in terms of actual access to the file system, but even access to the API server can be monitored and gated. You can enforce certain rules on the actual requests made to it, and same thing to the nodes themselves. No user should access the nodes unless they're from the internal team debugging them, and even then they probably should be using some sort of exporting of data via the API server and use actual access to the node as the last measure in case of serious bugs.
That's a good takeaway. Do not SSH to your either nodes nor containers if you don't have to. And I really hope you don't have to. Guy, let's go on to you, unless anybody has a question from the crowd. All right, Guy.
Yes. So I think one of the first thing about Kubernetes that when you're trying to run for the first time and use it, it's a very easy, fast, and awesome. Like you try to run your first deployment and it runs easily, fast, you have a lot of replicas and everything is very reliable. And when you goes into production, it's becoming a mess. Everything becomes so complex, they have a lot of moving parts. Everything is involved, the DevOps is involved, the developers are involved, and everything is becoming very hard to troubleshoot and figure out things. We can see a lot of people that going to the cluster and don't know really what to search for. And when it becomes so hard, people are struggling to find out what they are looking for. And one of the main and critical points that we see in Komodor is the fragile point between the DevOps and the devs and developers. So for example, one owns the infrastructure, he writes the YAMLs, he knows the resources, and he focuses about make the Kubernetes cluster runs well and the templates to be fine. And the others focus on the developing the code, make the code doing the business of the service. And this is a very fragile point for a lot of organizations.
So what is your take on how to survive managing applications over Kubernetes, even in those pain points where sometimes I think the line between DevOps and developers gets a little fuzzy.
Yeah, so
how do you make it more debuggable? How do you shift it onwards?
So I think there is like two parts. It's a very fuzzable line, and a lot of organizations draw the line in a different way. Like some of them are pushing a lot of ownership to the developers and make them think that they want to know Kubernetes, but at the same time, they don't know how. And on the other side, you have DevOps, they want to push more to the code side. And I think one of the things that we see common in organization is the liveness and readiness probes. This is a very critical point that a lot of services are failing to manage. Just to do an introduction about liveness and readiness. So liveness and readiness is the way to tell Kubernetes if our application is alive and it's ready to receive traffic. So you can configure it and Kubernetes will ask your container, are you alive? And we need to answer something. If the answer is yes, so everything is fine. But if the answer is no, Kubernetes is going to kill the pod, the container, make it restart. And it can be nice, and because you want to restart at the same time, but if you know how to configure the probes, so it's going to restart when you don't want it. So it can impact your availability and the time of the service is down. The other thing is the readiness probe, which means Kubernetes is going to ask you, are you ready to receive traffic? If you're going to answer yes, Kubernetes is going to send the traffic away to the service, to the pod. And if you're going to answer no, we are not going to receive traffic. So this is a very fragile point, because if the ready is saying yes, and the service is receiving traffic, but actually something is wrong behind it, the service is going to return 0 to the users. So at this point, you want to make sure like two things, like the service is ready when it's actually ready. And when you're going to troubleshoot, you want the service to be visible for you. So the first thing you're going to ask, how many pods ready pods I got? And if the answer is all of them, and the actually pods are failing, you're going to be in a very shit trouble. So what you need to do in that point is you need to configure them well. This is a very fragile point. How do you configure it well? It's like, it can be DevOps and developer work together. Like one thing is to configure them to make sure they are probes. You make sure the probes policy is matching to your organization or the service uptime. For example, how many failure you can tolerate, when you need to restart it, what is the timeout for each request. It depends really on the service business case. But on the other side, the developers need to develop and add code to make the liveness probes and the readiness probe actually be meaningful. So for example, in the liveness probe, we want to make sure that we can recover, like the service can recover, make all the DB connection to pull events from the queue, for example. In the readiness probe, we want to make sure not that it can be recoverable, is that actually can pull things and do the work. So we have the DB connection, not that we can recover from a failure, that we can access the queue. So all the things that depends, we should put in the readiness probe.
Right, that seems like very reasonable to know that your pod is one alive and able to receive traffic, and it's a completely different issue whether it's ready to receive it actually and not just able to, which is a good mark. So how do you survive debugging your Kubernetes application, your Kubernetes hosted application, if your pod is alive and ready, but something else happens?
Wow, okay. So this is a huge question, and every, I think, team is doing that the other way. And it's very hard because you don't know where to go. You need to go into maybe the logs to search for the error, or you maybe need to go to the metrics to see the rise of errors, but there's no way to start to a start point from that way. I think Komodor can bring a good value to starting point, but the organization and the dev team should know where to look for. If you have a bad logging, this is going to be a pitfall for you. So I think this is two good places to start from.
So how do you suggest, in many organizations, you sometimes have people that are a little headstrong in terms of the new things they are willing to take from another team. Let's say the new orders they're willing to take from another team. For instance, developers who say, I know how my application runs, I will write it this way. You go write the liveness and readiness probes, and I don't care about your policies. How do you become a good ambassador for that?
Wow. I think that there is like a mutual effort here, because both of the team wants the service to be very reliable. They don't want to wake up night. This is a very personal conflict here, that you don't want to wake up in 2 o'clock, try to troubleshoot. So I think they need to like come together, sit together. I think a lot of the issues is about more communication issues and not about actual problems in the services that they don't want to develop. So bringing everyone together in the same room, talk about the problems, make sure the policy is not reasonable, but actually good and fit for your organization. And then after that, you're going to sleep well.
Hopefully, because everybody likes sleeping. Nobody likes to be waking up at 3 in the morning with 20 missed calls from PagerDuty. Is there anything else you would add to your survival kit?
Yeah, actually, yes. Yeah, I think there's something like it's less common, but more like for the experts. It's about how Kubernetes kills your pod. So killing is something that Kubernetes very loves, and we need to make sure that we handle the kill well. So Kubernetes have a very well-defined termination process. First of all, it's going to send you a sig term, and it's a Linux signal that your pod is going to be killed. And after 30 seconds, it's going to destroy the pod completely. So in the 30 seconds, you need to do a lot of stuff. For example, if you have a DB connections, you want to close them. If you have requests, you want to make sure that you process them. If you pull up some messages from the queue, you want to make sure that you re-queue them. And 30 seconds can be a long time, but it can be not enough for anything. So at the point you have like 30 seconds, you need to make sure that you act the signal. You want to make sure that you close everything. And you want to make sure that if 30 seconds is not enough for you, that you can increase that by configuring in the YAML. So what about the main issue is not about the signal. The signal is not what the important here. What the important is
Just the flag.
Is just the flag. Yeah, and what you need to understand is that it's very hard to troubleshoot things, that you have many connections in the database, but you don't know why. You have a lot of requeues and like delay processing, and you don't know why. So this is something that we see a lot of customers struggling to understand where the problems come from. And they understand, okay, I have like best practices that they didn't implement here.
I'd like to give another type of example for a pod dying where nothing is actually wrong. For instance, you are running on spot instances. And your node just got the notification that it's going to go down in about, I don't know, 2 to 5 minutes or something like that. And your pod needs to terminate because otherwise all hell breaks loose in the background. So this is another important reason why pod termination processes should be very, very specific and practiced, because otherwise you're going to wreak havoc on your system and it's not going to be fun. Is there anything you can add to that?
Yeah, I think most of the things are going into the scaling down process. So when the system is scaled down, a lot of instances are going to shut down. I think in a spot instances system, it's very occasionally. So it's very common that scaling down or removing nodes from the issue. You have a lot of things that you can protect your deployment or your services by doing it. For example, pod's disruption budget, which actually protects your system and make Kubernetes not kill your pod very fast. And there are a lot of best practices to make sure that during a scale down, you actually have Kubernetes tuned to protect your system for a while. So I think this is something that people should take care of and be aware of.
Okay, so if we want to sum things up, we have two very important stages in the life of a pod. One is the startup and two is the shutdown. And those are parts that we can configure to help us run our clusters more smoothly. Because once the code runs, it's obviously, it depends on what code you pushed into it. But the other things we are a bit more able to control. Do any of the panelists have other questions regarding this issue, or somebody from the crowd? You guys are very silent today. Maybe you should go and grab a beer. All right, so we're going to go on to Tomer from Spot. Please.
Awesome. Thank you. So I do want to make one comment about your question earlier about other orchestrators than Kubernetes. I'll first of all agree that Kubernetes is the best one. But I think
I'm not sure if best, but it is the most common.
It's the most common and it's the most robust one, right? So best is kind of a subjective thing on the need for the job, right? Kubernetes is like the sledgehammer of container orchestrators. If you're trying to put a tiny nail in this desk, you probably shouldn't be using a sledgehammer. So we often see that, you know, the likes of ECS and Nomad and those lighter orchestrators, they lack a lot of functionality, but for a lot of organizations, they don't need that and don't have the skill set in-house to deal with it. It's just not worth it. I recently spoke to a Fortune 500 company, and they run 600 different Kubernetes clusters across about 300 teams.
Why? Nobody knows probably.
Because they were like, oh, we need to be highly distributed, it needs to be highly scalable, very robust. But then they quickly found out that all of their developers spend about a third of their day managing Kubernetes, which is insane. We're talking about like several thousand developers, which translates to tens, if not hundreds of millions of dollars a year in managing Kubernetes in-house. It's probably just not the right tool for the job if that's the way you're choosing to run it. If you do want to run Kubernetes at such a massive scale, you probably need to standardize, which is going to be a big part of your survival kit. It's deciding how your organization should run, how should it operate, and what are the best practices you're going to ask your developers to use. Now, obviously, it's really important to give developers freedom. It's an important resource. They should have the flexibility to do what's kind of like best for what they're trying to achieve. But I think at the bigger picture level, you still need an organization to operate and run, and you need your operations team to be efficient, and you need uptime, and you need to maintain SLAs. And I think standardization and developing in-house skills go a very long way in that. If you're choosing to use one APM tool versus another, slowly but surely you're going to build expertise in-house on how to manage it. And tomorrow someone's choosing something else, and you have a bug, you have an issue, someone needs to go and debug it, and kind of like you're saying, it makes it a living hell, really. How do we even get started? Who do we ask for help? How do we go about it?
Then you usually find yourself with that one person who actually read the manual from top to bottom, and they are so swamped with work.
Exactly. And if everyone kind of like stuck to the same tools, your chance of finding that person is so much higher, and the chance of getting to resolutions quickly is so much better.
Yes.
I have something to say about it. So you talked about having many Kubernetes clusters at scale, and there is a couple of solutions for that. Even before we're talking about multi-providers cluster, there's the Kubernetes Federation kind of architecture, which I think lets you have a single configuration for multiple clusters. I don't know if it works across multiple providers, but that's pliable.
So it would work across multiple providers if you choose to self-host it in every single provider, right? Like you can't federate AKS, EKS, and GKE to be the same thing, because they're not. You can have your own KubeADM or vanilla KubeSpray, kind of like your own in-house type of Kubernetes. Then you can federate it everywhere, but then you're going into everything she said about security and managing kind of like all of your masters and all of your workers and all of your RBAC controls, and the level of management becomes so much deeper. And then again, you have to standardize it. You have to templatize it. You probably want to use some sort of infrastructure as a code, or continue, with some delivery tool or provisioning tool that will allow you to use the same method and give those 600 teams, which we're talking several thousand developers, the ability to deploy clusters quickly, even if they're all managed and look the same. Still, if you're giving every team the freedom to deploy them, you have to give them the tools to do that with as well.
I agree, and I think that when we're talking about multi-clusters, I think this picture is becoming more and more real after the latest AWS outages. Big companies are asking themselves, maybe we shouldn't put all the eggs in the baskets of Amazon. Maybe we should more and more providers. I think that's the way of thinking when it comes to, for example, Auth0, that kind of company that allows other companies to use authentication services.
Yeah.
If they fail because they give all their money to AWS, the next step would be to go to the guy next door.
Yeah, I think it's a constant struggle in the industry. Companies need to manage their own SLAs on top of another company's SLA, and that kind of they're becoming so many single points of failure. Like what was their name? I forgot. That crashed about last year. One of the image providers for containers that kind of also you just couldn't launch almost any container because millions of different container images were stored there, and then they crashed for about 2 days. So that was hell. With AWS, even if their launch sequences kind of got back up on USCs like last month, the way you bootstrap EKS kept failing. So you couldn't even launch a new node because it couldn't register into the cluster. So you always have to manage some sort of strategy for your own, putting an SLA on an SLA, right? You get 4 nines, you're trying to go to 5 nines. That's 10 times harder. And it's the difference between like 50 minutes down a month to like 4 minutes down a month on a yearly average. And then you have to kind of decide how you want to manage that. And that comes with a cost, right? Like you go down, that costs you a lot of money, but also staying up all the time costs you a lot of money as well, and being safe for all that.
Speaking of staying up all the time and costing you money, I'd like to mention that one of the ways that many companies choose to handle their fear of downtime is by over-provisioning, which eventually, usually developers, and I'm really using the term loosely, most people don't really care how much the cloud bill is monthly to their bosses, but their bosses really care about that. So I'd like to get your point of view on what we can do to reduce our cloud bill and maybe not over provision what doesn't need to be.
Yeah, so that's actually a fairly complex task. And I wish it was simpler for organizations. Like I worked with like several apparel companies. They go to their developers and they say, hey, choose container sizes, small, medium, large, extra large, just t-shirt sizes. It fits our business. What are the chances you have 1,000 different microservices that fit into 4 molds of container sizes?
None.
And how many of your developers are going to choose one size up? All of them, right? When all of your developers choose to round their application requests up by 20, 30%, the organization spends another 20, 30% on infrastructure. And that's before we even think about the infrastructure layer optimization. Those 20, 30% for a lot of your companies, by the way, can be millions of dollars a month. I don't know how much you're talking to your IT team and see how frustrated they are when they get the bill. I think it's really important developers kind of think about day 2 operations, think about what happens to their applications if they scale successfully. It's really easy to take a deployment, give it 1 to 3 replicas, and even if you're off by a few percentages, it's not a big deal. But what happens when you go to 300, 400, 1,000 replicas of the same application, and every single replica is being inefficient about how it goes? I think the developers should invest the time on day 0, thinking about how they want to scale applications, how they want to do horizontal scaling across pods. And then once they decide what that looks like in day 1, find out what are the metrics that they're actually hitting. So almost everyone's using some sort of an APM tool, if that's Prometheus or Datadog or New Relic or SignalFx or anything like that.
Paid, non-paid, doesn't make a difference.
Yeah, doesn't matter. Choose the golden metric for your application, requests per second, throughput, can be also CPU and memory utilization, and make sure it scales by it. And then try to tightly couple the requests coming out of your pods to when that threshold of scaling is happening. So you don't want to scale at 100 requests per second when that means 20% CPU utilization at the same time, right? Because then you're wasting 80% of what you're asking for. Once you get those 2 things tied, coupled together properly, and then you make sure to tie infrastructure with it and make sure it scales efficiently based on those requests all the time, we've seen clusters drop their spend by as much as 80 or 90% in a week or 2 weeks worth of work. when just no one kind of paid attention to it at first. And again, hundreds of thousands of dollars a month in return.
So basically you're suggesting that developers take their time and think about something that usually doesn't hurt them that badly, over provisioning. Other than saying that your bosses care about the bottom line, which comes with the AWS or Google or Azure cloud bill, how do you suggest we put that issue into use with the developers?
So I know that smaller startups that only care about growth and kind of like top line is the only thing that matters won't bother about it as much. They can go, especially in how hot the market is today, they can go to the VCs, ask for a bit more money, get it, just continue over provisioning. But when you're becoming an organization that tries to maintain unit economics, that tries to maintain a healthy business, that tries to go public, those things do matter. Your margins matter a lot. Your stock price is valued by those things. What I see a lot of enterprises are telling their departments is, hey, this is your cloud bill. Every time you save X dollars off of it, you get another headcount. We don't mind spending that money, but we want something in return. We want output for it. A high cloud bill, spending a lot of money in the cloud is not necessarily a bad thing. If you have, hundreds of millions of users going onto your platform every day, that's going to cost you, but that's great news. It's better than a $0 cloud bill and 0 users.
So you're saying value for money. Think of the value for money.
Think of value for money. And then I think eventually it can translate, and value for money can be how many instances you provision. It can also mean how many developers your team can hire. And that's where I see a lot of enterprises are starting to go. They're trying to tie those two things together. And kind of warn teams, hey, you're becoming inefficient. Instead of being an 8-person development team, you're going to be 5, and your targets are not going to be any lower. You're just going to have to work harder. So do keep that in mind. Obviously, the healthiness of your business. Most developers tend to also have options, stock in their businesses. How successful they are does matter to their own pockets. And I think, kind of being a good corporate citizen, so to speak, is an important thing for all employees.
So other than what we've talked about, is there anything else you think that has to be in your survival kit?
Automation, and a lot of it. So that part does often fold into the ops side more than it is to the developers, right? So expect your ops team to deliver automations for you. Make sure that you are able to be efficient in your work and you don't spend 30% of your time managing infrastructure, hopefully.
Because that's not your business or core values.
Yeah, it's not core value. It's not your differentiating work. It's not what's making you a successful business for most businesses, right? And kind of just make sure that your business is adopting as many automations as possible that allow you to keep pushing code, not worrying too much about day 2, not worrying about what's going to happen, but making sure it runs efficiently. By the way, one other small comment about over provisioning. Yes, you can constantly scale up, but then your application can also get shut down eventually, right? If it's so wasteful and it's not making enough revenue in return, the business unit might just not make sense. And it's just because it's been too splurgy and not because it's a bad product. So, think about long-term implications. I know short-term is always easier to focus on, but it does does go a long way if you think about it ahead.
I want to add something to the automation part. There is at least one part of the automation that developers can control, and that's testing your applications. The more tests you put in your applications, the more safe you feel in deploying them, and the better you know how they behave in production. So test, and if you can, test them for load as well. That will help you eventually achieve the goal of knowing what your application can do and how many resources do you actually need to provision for them. Does anybody want to add anything, ask anything on the subject?
I have a question following Tomer comments about managing multiple Kubernetes clusters. What is in for everyone in the panel? What's your approach for managing multiple when you decide to combine multiple workloads? Cluster, especially in scale, especially when we have
so I do think a lot of companies will have different reasons to do that. Some of them is just organizational behavior, right? You want to make sure different developers deal with their own department's overhead. I've seen companies choose to load balance in front of Kubernetes and then have a single cluster per availability zone. This way pods are not being chatty across AZs and you're not spending so much on data transfer costs. And that's if you have a very chatty application, that's going to matter. If your application is not too chatty, maybe you can solve that. Maybe just at the pod level, you could also manage it. But all of those things include overhead, and it depends on what's easier for you to manage. I think if you have the expertise on Kubernetes, you can leverage very, very large clusters that have a lot of complexity built into them. Most organizations don't. If you're a DevOps engineer and you can do that for your business, your job is going to be very, very safe.
Probably.
So the original question was, when do organizations choose to run one very large cluster versus multiple small clusters, a single cloud versus multi-cloud? And the answer was what I said, in my opinion, at least.
So I think that the question of multi-tenant and whatnot about that is mainly an application concern, usually, but you should also take that into account in the cloud. And if I already had the role of being the security angle, so especially in security, I mean, if you didn't have any budget, you would probably want to just run anything on a single cluster, because that's the most secured way to actually be sure that anything on the cluster is configured exactly like your microservice or product needs. It won't have any less or more resources or access than it needs. But of course, in the real life, you want to be able to share, because you can't have lots of nodes for a single application. And also you might have the concerns of what the other nodes may contain. For example, our application may run on the customer provided cluster, and there it might be sharing the same node as customer code or other providers the customer is running. You don't want, as the customer here, to allow the code to share resources with code of a completely different company with completely different business logic and agenda. So you need to take notes of that. For example, we are using some logging agent that we are not, that we need to run on every node using a daemon set. And we can't simply run that on every node when we are sharing a cluster with different applications. Again, you need to be very aware of the security measures when you try to save money.
What about debugging? No, that's actually was your part. What about making it more debuggable? And what are the considerations in multi-clusters in that?
I think one small answer is you need to keep it as the low number of clusters as you can until you got a barrier that you can't go through without adding another one. So always keep in mind that you want to keep it lowest, but you need more for something. Mm-hmm.
I don't have a long answer for that. Larry just took the words out of my mouth, so I'll just keep it simple. The first question you gotta ask yourself is security. If not, keep it simple. Really, it's gonna make it much more easier for your dev and DevOps.
Well, the less resources you have, the more secure it obviously is, and it's easier for you to control it. So yeah, KISS principle is always best.
I agree.
Anybody else wants to ask a question? Or are we going to give Gilad his time to share what, what goes into his survival kit?
Okay, so if we're talking about survival kit, and of course I'm gonna talk as a developer for developers, I'm gonna talk about responsibility, because I see many companies talking about the shift left movement, the shift left kind of ways, is giving the developers more responsibility from design to production. But in many companies, when it gets to production, it gets to, they say, okay, dev, you've done enough, now that's the DevOps way. But in most ways, you find yourself, your DevOps calling you in 4 in the morning, asking you what the hell is going on with your pods, why are they on fire? And I really think that there are many tools that give developers being more intact and more on their pods. You as a developer will learn so much, even from regular daily, just idle. Think of your pods being in idle state, just to check up on them. Just open the cage to see if they're fed enough, if everything's cool with the CPU and the memory. Okay. Because many times you just find yourself doing this, like, I'll say once a week kind of checkup, see that your pods are okay. And you might see that you have like a great increase in your memory if you're not looking at your Datadog / any other APM provider. So for a survival kit, when it comes to developers, I'm gonna, I see you wanna have a question.
It's not a question. It's actually, I think that in terms of ownership, when you own the code that you upload to production and you wake up at night because it doesn't work, it makes you want to write better code. It makes you want to test it more. It makes you want to make sure that it doesn't wake you up at night. And when you give the ownership of your production environment, when you give the ownership of your production environment and how it runs to the DevOps who don't necessarily understand the business logic of everything that you did, they're going to call you in the middle of the night and they're going to be angry with you because they have to wake up in the middle of the night and debug applications that they know nothing about. So if it's your code, own it.
I completely agree. And you can make the life for the DevOps even easier. So let's say that they do check up on your pods more lately than you are. You can use Kubernetes as a way to speak to your DevOps. And I'm talking, let's say, about the most basic kind of way, and we talked a lot about it, is about the life cycle of the pods, and specifically on killing pods. And I don't know if you've ever been, if you were ever scared looking at your pod and seeing a crash loop. And seeing a crash loop might be a bit scared, but that's a very good way of knowing if your pod is, it needs some help. Because a very good practice that we implement in Rookout is setting your, let's say that the first part of the code, you're looking for any environment variables or any specific configuration that your code needs. And if we don't get it, we panic. I'm writing in Go, and in panic, it means that we blow the app up the air. And in that case, the Kubernetes will try to start the pod and it will fail because it is missing a configuration. It will fail and it will fail and it will fail. This will make sure that the DevOps or UR will know that this specific pod is on fire. Now, let's talk about something, let's talk that this isn't your DevOps. Let's say that you're deploying to on-prem, to your customers, which you use it on-prem. Now, you don't want your customers or they're the customers' DevOps, the DevOps you dislike even more. So you want them to know as much as possible because you don't want them to call the solution engineer of your company, which will have no idea on what's going on. He will call to you. You could just eliminate everything and give much more information. For example, if you want to, you have your code is like 3 pods and they're coupled a bit. You can just check if everything is okay. And if it isn't, you can crash it, because if you wouldn't, the DevOps will deploy your solution, will see that all of the pods are okay, and just say, okay, everything is okay.
But nothing works.
But nothing works. And they see 3 pods, each of them is 1 out of 1. And now what do? Do they need to go into the logs and look at the logs that they have no idea about? It's hell for them, and
you don't want people to hate you.
Yeah, and even I'll be a bit more aggressive about that. It could fail sales, because you might try to sell this product to the customers, and the DevOps will say, "Listen, the product is just unprofessional. We can't keep up to that. We can't maintain it." So having that kind of feedback to the salesperson it might just ruin the whole deal. So that's very, very important.
And it might not just ruin a deal because customers have a way of talking to each other and finding each other, and people like to complain. So if that kind of situation happens and you have a very angry customer that is going to start talking about the fact that I can't work like this. This does not give me proper error handling. I don't know what's going on. Basically, it seems like it's up, but nothing works. What do you think that's going to do to your business in general? It never bodes well.
Yeah, I agree completely. We all want to be as much as professional as we can. And definitely as a developer, you need to know how the orchestrator operates. It will make things way much more easier for you and everyone else that you work with. I want to give an example that happened to us, and I'm going to really talk about it from the developer perspective. What happened to us is we use a database that is managed by a provider, which is Google. And I don't know if there are a couple of advantages and disadvantages for having a managed DB, but one of them, which is a mix, is having regular maintenance windows, which they update the DB and they just do it. Well, you know when it happens, but it has some implications on your code. So what happened was they updated DB, or they update the Redis, or everything we use, and it just shut down every connection we have to them. And so we just saw all of the errors, and there are two ways we could reach that. There are a couple of ways which we saw a solution to that. One way is to say, okay, let's just look at it as a dev. Do I need to maintain my connection pool differently? Do I need to retry everything? But the most simple thing, the most simple thing that we did was just say, okay, let's just restart the pod. And it did, and it just worked like a charm. When we started the pod, it just worked. So when you have a maintenance window and it just updates, like I'm gonna say every 2 weeks, or maybe a bit more, you have, let's say, your Kafka and your Redis and your DB, all of them are managed, and we needed to kill our pods in a good way. So what we did was to talk about the Liveness Probe, because Liveness Probe is the way of Kubernetes to know if a pod works. And so we implemented on every service that we had a health check API on /health. Check if you're connected to the DB, to the Kafka, to the Redis. If not, send that you're not okay. Because enjoying this kind of perk that Kubernetes has, which is controlling the lifecycle of the pod, will make everything much easier for you, because this is what we did. We implemented in the way of this API, the simple API service, /health, you're okay. If not, destroy yourself.
Kill it with fire.
Definitely.
And it's always fun saying
To
kill
say
it with
it.
fire on something.
Yeah, and it works pretty well.
Yeah, definitely makes everyone feel better. Actually, we have a few questions from Zoom that I'd like to ask everyone here. Unless there is any other specifics that you want to add about production incidents that you experienced and how to survive them.
Nothing in particular, but I want you to know that if you're dealing with Kubernetes, because this is open source, there are many, many tools that let developers get into just under the hood and see if everything is okay. For example, if you want to open a Wireshark inside your cluster, is it possible? Yes. There are a couple of plugins. One of them, the easiest, called Sniff, would just let you sniff inside the cluster, see if everything's okay, which is super helpful if you're running locally, but would be extremely helpful if you're running on your production. So there are many, many ways of just baktana that give you just this extra step of knowing your cluster.
We're going to come back to your favorite tools and how to use them a bit later,
Okay.
but we're going to go to the Zoom questions. So question number one, how do you manage the conflict between devs and DevOps teams about resource requirements? Or should you actually?
Well, in my perspective, that's I didn't remember who said it, but it's all about communication, because the development, the DevOps have their own agenda of using as little as possible, so they wouldn't need to manage as such. And developer side will be like, I don't care, just scale it out and I can manage it all. So it's all about communication. And I think when it comes to these two parties, it's always good. There's a one authority that just give them, listen, there is a very limited, we have limited resources. So everyone need to chip in. And when it comes to developers, you would need to use, you would want to use as low as much, because it isn't just good for the developer, for the DevOps to use as little as resources. You would want to use as little as resources, because going up and up would just mean, which would just return as a boomerang to the developer. Even to rewrite everything, finding just finding why do you have a memory leak is a reason for another talk. So it's all about communication and finding the middle way.
I think we actually talked a lot about this before. I think
Yeah.
you mentioned a lot of the solutions.
Yeah, so I think obviously communication, by the way, solves about 90% of all problems in all organizations. The better people communicate, the less issues they have. But what you can't communicate, automate. So I think it's the Netflix approach, but basically the idea is just take a pod or a container, throw it into a cluster, and whatever, just throw a number in there. This container is going to need 50 vCPUs and 200 gigabytes of memory. A great microservice. And then tell the automation tool what's the golden metric, 100 requests per second. And if you're hitting that, then redeploy the container, do a continuous delivery automation, where you redeploy it with 10% less requirements. You're kind of taking continuous delivery, some APM monitoring, and then a GitOps approach to all of it. And then make it 10% smaller. Is it still hitting the golden metric? Great, redeploy 10% smaller, and again, and again, and again, and again, until it doesn't. Then go back to the less size, and then you get a fully autonomous, not just infrastructure, but application sizing. Then you have to make sure you kind of have those two flywheels. The first one is automating what the requirements are coming out of the application. And the second one is automating the underlying infrastructure and making sure it's tightly coupled to the real-time requests that are coming, which is a constantly moving target. And I think if you're able to achieve that type of automation, then obviously you'll solve a lot of the communication issues. You won't rely on human errors as much. But it's obviously not simple in itself, and sometimes might require a few developers just to maintain something like that. But there are a few tools out there in the world that do some of it or all of it.
Anybody else have anything to add?
Yeah, I think Kubernetes is a very different way from the sizing of VMs that we used to have. Like you have to, month ago, decide and make a decision about the sizing. So in Kubernetes, you can do a trial and error, which is kind of nice. Not in the first time, but actually you can optimize. For example, if your pod is not getting kinged by out of memory, you maybe can reduce a little bit. It can take time, but you can optimize very well. And you don't need to be afraid about pods getting restarted if you're doing it wisely and safely. So you should take Kubernetes and your pod maybe to the extreme, and you can do it safely if you know how to use the tools. So I think it's something that you should take into consideration.
And I think that if you utilize the liveness, readiness probes, and the shutdown processes that we discussed before, it makes this trial and error a lot safer, which is awesome. And we're going to move on to the next question. What are the policies in development for Kubernetes that developers should cover? Policies? Other than having all the pros that we discussed in the policy regarding the life cycle, is there anything else that you want to add to that? Yeah, I think we kind of discussed most of it.
I think we cover most of the issues, but I think we need to just to make sure you implement everything well and not just implement it, because it's not done by that. You need to make sure like your liveness and readiness probe are different and things like that. You need to be very well organized and very well defined to your best practices.
Okay, actually, the last question we had from Zoom is one that we have already discussed regarding thoughts on K8s running in hybrid environments in terms of security and or better management. So if there's anything to add on that subject. I think we kind of covered it. Do we have any other questions from Zoom?
I want to ask Gilad one question. So you talked about the advantages of crash looping, but obviously you don't want your process to always crash loop because then you won't have availability. You might want to be highly available rather than crash, especially on a customer environment. So I wanted to ask if you have any tips about how to discover problems in clusters you don't manage without crashing your pods.
First of all, I can just slip in first a bit of commercial. Rookout deals with it pretty well, but there are other ways that Kubernetes lets you give in more tips from your code to the outside, and one of them I think is a spec that's under each container, which is I think like termination error path. Which is a path inside the Docker, which you can just write from inside the code what went wrong. So if it just nothing that it is crash loop, crash looping, just a simple error, you could just write to that, and have your I think even in the events of the Kubernetes you would get that, because Kubernetes would mark that pod as an error, write it in the events, and you would be free to go. And also loggings, of course, which is a good way, but sometimes, if we were talking about on-prem DevOps, I'm not sure like how would they react to looking at other developers' logs. So no, that's a good way. And if you're very, very lucky, and the on-prem of the customer that you're deploying to, they let like a single way. There's a single and an API into your that would just send everything into your log provider. You would just see it even right in your home, but not. I don't think many cases would allow that. Do you have like any special kind of ways of knowing other than crash looping?
Yeah, so it's a problem we have, especially in environments that don't allow for sending stuff outside, be it monitoring or errors. Basically, you need to be imaginative and find your way. You can leverage Kubernetes APIs. As Gilad said, you can write to certain paths. You can even use Kubernetes API itself to write events. Any warning event is considered error, so you can rely on a good DevOps team to notice it. But of course, you want to be ahead of them and not have them approach you. And in a very isolated environment, air-gapped even, you just don't have that.
Yeah, it's usually a problem when you don't have access to the location where you're actually running everything. And this is a problem not only with Kubernetes, but even in the pre-Kubernetes era or with any other orchestrator that we're ever going to touch.
At least now everyone are Zoom experts. So you got that.
Yeah, you got Zoom, you got your ability to write meaningful logs that will actually help point someone to the right problem. And as always, most solutions are between the chair and the keyboard, as are most errors. So do we have other questions, or do you guys want to continue having an excellent general discussion? Yay, more questions. So we got a question about what about developing ML algorithms and HPC apps on K8s? Any thoughts on that?
Yes, a lot. So I think that also connects to the last question we've had from the previous batch, which is what do you do when you run a hybrid environment? Some of the reasons we see customers run hybrid environments is most multi-cloud approaches tend to be different applications on different clouds. One a bit more extreme edge case is I ran out of resources in my data center, but I need to keep scaling my application. So I'm using the same orchestrator. I'm trying to take workers from the cloud. Obviously, there's a lot of complexities in allowing that to happen. A lot of security concerns. You have to make sure a lot of the control plane goes in one-way links and so forth. But one of the things that brought us there is the idea of running machine learning models, Spark applications, and big data workloads in Kubernetes. And I think Kubernetes and microservices generally are a perfect fit for that. So, when Spark, for example, came with Yarn, which is like some abbreviation of yet another resource scheduler or something, the idea is that you take one job and you put it on one VM. But the reality is we're going into the same issue of over provisioning. The job is using 70%, 60%, 40% of that VM. But because it's connected to the kernel and everything underneath it, you can't throw another job at it. When you use microservices and you use kind of like this distributed architecture, you can actually get, again, a lot more bang for your buck, a much better ROI on how you run your workloads, and just utilize those same resources that you already get provisioned so much better. And I think we're going to see a lot of the traditional HPC schedulers, a lot of the machine learning models, the TensorFlows of the world and whatnot going into containers. There is a limitation in the world of GPUs right now, where you can only connect one pod per GPU. So you can still have waste there, right? Like even if you're using like only a fraction of the teraflops available, you can't throw another pod at it. But eventually that will get solved. That's the beauty of open source, and someone's going to figure that out somehow, and then we're all going to enjoy it. But once that happens, we'll see more of machine learning capabilities in there too.
Grateful answer. Anybody has anything to add?
Yeah, I think especially in machine learning testing environments, you have this kind that you need to use GPU, and GPUs are extremely expensive in the cloud. They are, I think, they are the expensive machine in the cloud, and you want to optimize well what you're running on the GPUs. So I think one thing is about know the scale, because you need to be, you can't fail in that way. If you run like GPU machine for 1 week that you don't need it, it's going to be a lot of money. And the other part is to be very smart on your node management. Do I need auto scaling or not? When can I reduce the time? Which algorithm or testing subset I can run on each node and things like that. So you need to be much more smarter about scheduling and not trust only Kubernetes to do all the scheduling for you.
Yes, usually you should do that. You shouldn't always trust a service, especially a paid service, a managed service that you don't necessarily run, to do things for you that you naturally expect, but doesn't mean it's going to happen.
Mm-hmm.
So yes, be involved, know what your service is doing, read the manual on how it's running things. But again, we're getting to the point where this is the little fuzzy end between DevOps and developers, because sometimes we don't know, is this something that DevOps should do? Is this the manual for the DevOps to read or for the developer? And as you said before, this is a pain point in many organizations, because there is no golden rule. Every organization decides on its own. What is dev and what is ops? It's the same way that DevOps in every organization is different, because DevOps is a culture and not a job. in my opinion. So yeah, it's a fuzzy little moment there.
And I think machine learning bring like more people to the table, like data scientists, data engineers, people that are really don't care about running workloads. They just want the algorithm to run on the GPU.
Just
so it's
give them
become quite harder.
give them something they can SSH to and they'll be fine. Otherwise, leave them alone. And if you manage to teach your data scientists on what is Kubernetes and how it works, you have upped their worth in so much, and you should never let them go. Keep them, hug them, call them George, do whatever you need. Don't let them go. They're important. They are not the cattle of the world. They are the pets. So I want to continue to our next question, which is actually, it's a good discussion. Why not use a platform as a service like Cloud Run, etc.? Why this overhead on a cloud provision when you can have platform as a service? Anybody wants to tackle that?
So as a quick disclaimer, what we do at Spot is sort of a platform as a service capability as well, right? We offer a set of tools and automations to run Kubernetes. So for example, we have a fully autonomous Spark on Kubernetes. So your data scientist can just throw a model at it. We'll make sure it infinitely scales. It schedules the containers, it bin packs, it does all of that.
That being said,
obviously, there's overhead, there's costs to adding vendors as well, right? You have to make sure you're getting the best use out of your vendor. You're leveraging everything they're giving you. You're, making sense of a broader strategy. Using a platform as a service gives you yet another point of failure that is not your business, that you can't control.
that you don't know how it runs, which is exactly what we've discussed before. You're giving someone the handle on your money without knowing how it works.
Exactly. And, some of them will give you better or worse visibility. Some of them, will give you more clarity and less clarity about their backend and their stability. But that always includes risk, I think. And it has, even multi-cloud type vendors like we are also a sort of a lock-in at times, right? Like you're becoming dependent on using some platform to orchestrate your infrastructure. And then you're trying to go on-prem all of a sudden because whatever happened, you're trying to sell to a customer that won't work with you in the cloud. And no one knows how to do that because everyone is reliant on cloud native platforms. So, there's cost to everything. There's overhead with everything. I'm obviously a big fan of platforms, but I'm biased. But there's pros and cons for sure.
Okay, I think that's actually all the time we have today. And I'd like to thank everybody for joining us, both our viewers back home, you guys for coming, and our awesome panelists for taking their time to educate us. So thank you very much. And so the raffle will be announced in 15 minutes. So thanks everyone for joining us, and grab a beer.